So guys, welcome back and welcome to another brand new video. I know it's been long since I last uploaded. I have been busy with some stuff, but now I will try to re-upload the videos again from time to time. So without any further delay, let's start our today's daily question. That is search in a rotated sorted array. It is a very common question asked by so many companies from Google and Facebook. Every other company has asked this question so many times. It is a very good question and it can be solved easily if you look at the constraints and try to think about it. So I will give you a minute to think about it and then come back to the video. Okay, go ahead. So I hope you tried the question, and if you have looked at the question, you will see that it can be easily done in linear time complexity, that is O of n. But the trick here is that they have told you to do it in O of log n. And whenever there is log n complexity, the first thing that should come in mind is binary search. Also, whenever you are doing these questions when there are sorted array, you can always think of binary search because binary search only works with sorted arrays. So that is the trick here. To get that, you have to apply binary search. So linear time complexity, I think you can easily do. You can iterate there and see whether this target is available or not. If it is not available, you will return -1, and if it is available, you will return the index of that array. That is 0, 1, 2, 3, 4. That is 4 is our output. So how will you apply binary search in this case? Because they have told you that it is a sorted array, but trick here is it is a rotated sorted array. They have rotated it several times and they have not told you how many times they have rotated it. So you have to think how will you approach it. So hint is you will apply binary search and it is rotated, and even after rotated it will remain sorted in some parts. So think around it and then come back to the video. I will give you another 10 seconds to think about it and then come back to the video. So I hope you have tried the question. Now move on to the first example and let's see how can we apply binary search to it. So when we see the first example, initially it must have been like 0, 1, 2, 4, 5, 6 and 7. So this must have been in the initial array, and if you have rotated it 4 times, you will get something like first 7 is rotated, then 6 is rotated, then 5 is rotated, then 4 is rotated, and then rest of your array is same, that is 0, 1 and 2 remains same. So when you have this array, you can see that every element from 0 onwards is increasing, and every element from here is also increasing, but after this element it is decreasing. What I mean to say is half of the portions of this array is already sorted, so that it is already sorted. So what we can see is there is a consistency that 4, 5, 6, 7, it is in increasing order, and after the certain point when it start decreasing, it is in decreasing order from this perspective, that is every value right to it is lesser than these values. Okay, and it itself is increasing order, that it is also sorted. So what I mean to say is after rotation certain times, your array will be sorted in half manner. Half of the arrays will be sorted, and every value towards like if this is the discontinuation part, whenever we encounter a lower value, every value here is lesser than these values. That is 0, 1, 2 should be less than all these values, that is 4, 5, 6, 7, and that is the case. So what we can see is it is strictly increasing in the first half, then it decreases, and then it again is strictly increasing. So that point we have to find and apply binary search on it. So how can we actually do it is the real question here. So take a hint and try again and then come back to the video. So I hope you tried the question again, and now let's move on. How can we do it? So we see that 4, 5, 6, 7 is increasing, and after that it decreases and then again start increasing. That is the graph I showed you, like this, increasing then decreases and then again start increasing. So how do we apply binary search? So binary search is like the pattern is similar, but how do we apply it here? So we have to see some things. Our target is 0, so our target element is this 0, 0, 1, 2, 3, 4, 5 and 6. So total elements are 6. If you apply binary search, you need to get the mid element, and what will be the mid element be? It will be 6 by 2, that is 3. So our mid element comes out to be this 7 in the first case. 7 is the mid element now. So first our mid element is 7. So what we can check? We can check that start is here, end is here. So we will check whether this mid value is greater than the start or less than start. Okay. And after that, first we will check if start value, whatever start value is, greater or less than the mid value. We can check that. After checking that, we need to check another thing, that whether this target element is in this range or not. So let's say our mid is 7 and it is greater than our start. So we will check whether our mid element, that is mid, is greater or less than this target. So if our mid is greater than or less than target, that is, we need to define it in this range. So our target value should be less than the mid value, that is, mid should be greater than the target value. Mid should be greater than the target value, and start should be less than the target value. Less than the target value. So by that we can simply say that it is in the first half. If start is the boundary, we are setting simply boundaries of this. So if our target is in between the range of start and our mid, mid is our end boundary and start is our starting boundary. If our target is between them, we will move our end to mid minus 1. If it is not the case but our mid is greater than the start, so what we can do, we can do start is equal to mid plus 1. That is, we will search it in the second half. So now our start will move from here to here, and now we will start searching for a target element. So if state is that if start is greater than mid, then we need to write another else from this bigger if, that will check that if our mid is lesser than start, then we will again apply this condition, and then it is the condition of second half. So what we can say, that our target should be greater than mid. Yes or no? We are simply setting the boundaries. Target should be greater than mid and our target should be less than end. So that is what we have to find. And if this is the case, if target is greater than mid and target is less than end, that means it is in this area. So that means we can find it. And if we can find it in this area, that means we have to move. This was else condition, and inside this else, this was the first if condition. And that means it is available in the second half. So we will move our start is equal to mid plus 1 to find that element. And if this is not the case, we will move our else to, we will move our end to mid minus 1. It will get more clear in the code part when we code it, but overall idea is we have to identify whether it is in the first half or the second half. Both halves are increasing on their own, and we have to figure out where our target values lies. So that is what we have to do. And once we know the half, we will keep moving till we find it. And what's the base condition of this binary search? That if our mid is equal to our target, we return the index. We return the index, that is mid index we will return. So that is all we have to do. So without any further delay, we can move on to the coding part. If you have understood this explanation, we have decided how to figure out where the target lies, and both are sorted in their own order. That way we can approach it. If you have understood all this, you can code it on your own. If you have any issues, please comment down and let's try coding it. So for coding it, let's just zoom it. We will do our simple binary search approach, that is, we will decide our start is equal to 0. We will declare our end to be the size of the array minus 1, and we will start our binary search, that is start is less than equal to end, and we get the value of mid is equal to start plus end minus start by 2. We get it this way to avoid buffer flow. And after that we do our search, that if our nums of mid is equal to our target value. If we got the target value in the first mid, that we can return the mid index. If it is not the case, we will check whether our nums of mid is greater than the start, is greater than or equal to the start. If our value is greater than the start, what we can do, we have to apply another check. That means it is in the first half if this was the case. So we will do like if our nums of mid is greater than the target, greater than or equal to the target, and our target should be greater than the nums of start. Nums of start. Then we can say it is in this half available. It should be nums of start. So that means our target lies is between the range of start and the mid. So what we can do, we have to move our n to mid minus 1. And if this is not the case, we will move our start to mid plus 1. Also, if our mid value is not greater than start, then it means it is less than start. That means we are in the second half. So if we are in the second half, we will apply the same if condition, but this time our mid value will be the lower bound. That is, our mid should be less than equal to the target, and our target should be less than the nums of end. So it will lie in the bound between these. So if it is true, then we can move our start to mid plus 1, and if it is not the case, we can move our end to mid minus 1. So that is all you had to do, and if it is not available in the array, we will simply return minus 1. So this is all you had to do in this question. The only thing was getting that it was an increasing array after rotation, that half of these are increasing. It is increasing and it decreases at one point, and it is again an increasing array, and we only had to decide on which side of the array it lies, our target value lies. That is all you had to think on this question, and it is done. Let's try running it. So yeah, it is working. Let's just submit and check whether it is accepted or not. So yeah, it is accepted as well. So this was all for this question. If you have any doubt, please comment it in the comment section. Please share the video, like the video, and your comment means a lot. Comment other questions you want me to solve. Thanks a lot for watching. Bye bye.